Okay, so today we will start neural network. If we think it in simple terms, it's basically the copy of our mind. So the mind,
Mhm.
how our mind works, it's basically it's written in the algorithm. So in in our mind, let's say we see something,
Mhm.
and in response to that thing we try to learn some factors through that we can remember that thing, or we associate some things through which we can at least memorize or remember or learn something from it. So
Mhm.
the neural
Yep.
network actually works in a similar manner. So it has neuron,
Yep.
or we call it node. And to this neuron or to this node we get inputs. So in human mind, these inputs can be any input from our senses. One, input two, input three, input n. Within this neuron, we have some function through which we trigger whether we want to memorize that thing or whether we want to learn that thing or not. Because in our daily life, we see that sometimes we do tend to remember something, sometimes we don't tend to remember something. We ignore certain things. So similarly, in neural networks, we have this function that's called activation function. Based on these inputs and our function, we get our output. So this is
Yep.
our output. This is like very holistic, very general idea of what is neural network. So in today's session, we will be going into maths behind it. The diagram that we saw previously, it was like this one, and it has an input on it and one output. So this is this node, and we call, if there is only one node, if there is only one neuron, we call it perceptron. These are the inputs that we talked about, and this is our
Androids. Yep.
so this G function, this is actually our activation function. This is our output. So the output can be single output, it can be multiple outputs depending on our data. The outputs can be a single output, or it
Mm.
can be multiple outputs as well. For example,
Yep.
for example, we have, let's say, picture
Yep.
picture of a cat, and we put it in a neural network. So the output can be in terms of probability, the output can be, this model is sure that this is 0.6%, 0.6 or 60% this image is of cat,
Mhm.
but it also says that there's 0.4 a probability that this image is of dog. So we have two
Yep.
probabilities in this case. Or in terms of single output, we can say that, let's say we have some time series data of electrical load.
Yeah.
So let's say we have this time series data of our electric load, and we are putting this in our neural network. So it gives us a single output. Says that maybe at time t, the load is, let's say, 2 megawatt. So it is giving us only
Yeah.
one output, that at this point we have this load. It's not giving us multiple outputs depending on the model. So this model, we can call it as only single output input. So the input is basically our any vector that we are giving here. So these thetas are this vector. I have a very simple diagram as well, this one. So this is the same node. These are the same inputs. These are the weights. These inputs multiplied with the weights here, they are being added here. And after that, the summation, the product, the answer to this sum goes into this activation function. In the neural network, we also have the first input or S1 as a. So if we, let's say, explain this only term, summation, so it will be x0 into theta 0 plus x1 into theta 1. So here it's written w1. We can write theta 1 or we can write w1. But most of the
Okay.
text actually writes theta. So we will consider thetas. Okay. Then x2, theta 2, and x3, theta 3, and xn, theta n. So once we have the summation, or basically these all variables will have some numerical values in it. Maybe 1, maybe 2, maybe some sort of float, or any numerical value in it. So that numerical value we will put into this activation function, and that activation function will tell us whether we want to uh, remember that node or not. It can be from 0 to 1, and that output then is saved in this a variable. So we have talked about how single perceptron works, which is this one, this entire thing.
Mhm.
And once we have many perceptrons, or once we have multi-perceptron, it becomes a neural network then. Yeah. And when you're talking about neural networks, so in neural networks, we have one input layer. That's the first layer in which you give your inputs. And the output layer through which you get your output or predictions. And all the layers in between the input and output will be our hidden layers.
Right.
And these hidden layers can be from one to many. It depends on how complex your model is, how complex your data is. So the weights, we talked about these weights. So since each perceptron will have its weight, so these weights in neural network will be represented here. So on these lines pointing to the hidden layers or to the different nodes. So there's like a mathematical representation. How do you define how do you actually represent the theta or the weights for this layer, or the layer between first and the input on the first layer, first layer and the second layer. So all will be called thetas, but with different notations, with different subscripts. So all the nodes in the hidden layers we do know is by each node. So if the node is one, if it's our first node, then it's A0, then A1 up to AN. And if the node is in first layer, then it should have superscript of 1 here. And here we write A0 or A1 or A2, depending on the which term we are talking about, this, or any of the node. This is how we do. Now we will just see how activation function in each node will work. We will work out for maybe 2 or 3 nodes, and then we will get an idea that how this is working. Yeah, before that, let me just tell you about this theta. So when I was talking about the weights or the theta vectors, so this is our 0 vector layer, this is our first layer. So the theta vector, the weight vector, we call it theta1, because the theta vector can contain many weights in it. We need to determine which weight we are talking about. So there will be a weight on this line, there will be weight on this line as well, there will be weight on this line as well. So all the lines will have certain weights on it. So we need to figure out which weight we are talking about. We can do this using the same notation, the theta1. We write theta1. This means that we are talking about all the thetas which are between layer 0 and layer 1. We talk about the subscript. So the subscript basically tells us that which weight we are talking about. So to read in this direction, in the left direction. So 0 to 1. This means that from x0 to 1. So let's drive actually this equation, how this equation is formed. So from the diagram, we can see that this node has arrows or the weights from all the 4 inputs, 2, 3, 4. So it will have four products, and then we combine these 4 products. We have solved up till this point A1, A2, A3. Now this theta2 vector as well for the weights which will contribute towards our output. So same process that we did for A1, A2, and A3, we will do the same process for this A1 subscript 2 as well, superscript 2.